Hello everyone, we are doing 2025 Level 2 Calculus today. Starting with the question 1, A says f of x is this. Use calculus to find the gradient of the function at the point where x equals negative half. So we have to differentiate the function, which is a 6x squared minus 6x plus half, and then you plug negative half into it, and you will get 5. So gradient is 5. Easy. Question B, for the cubic function, find the equation of the tangent to the curve at x equals 2. So as you know, the equation of a tangent is y equals mx plus c, isn't it? So you have to find the m first and then c. Now to find the m, we have to differentiate the function. So which gives me negative x squared plus 4x minus 3, right? And then what we do, we plug 2 into this function, and that is negative 4 plus 8 minus 3. Sorry, this is 8, equals 1. I'm gonna rewrite this 8, right? And then so we've got this much, y equals 1x, which is just x plus a c. To find the c, we've got to know x coordinate as well as y coordinate. So x coordinate is right there too. So we have to find the y coordinate when x is 2. So when you plug 2 into this function, you will get 16 over 3. Okay, so it becomes 2 comma 16 over 3. So not only this cubic graph passing through 2 comma 16 over 3, but this tangent as well, right? So you plug 2 into x and 16 over 3 into y to find the c. So when you do that, 2 plus c equals 16 over 3. So hence c equals 10 over 3. So that makes the equation y equals x plus 10 over 3. All right. Next, question C. The gradient function f prime x is given by that. Find the equation of the original function f of x if the y value of the local minimum is equal to minus 46. All right. So what we have to do is integration, isn't it? So f of x should be 2x squared plus 2x minus 24 dx. So that becomes 2x cubed over 3 plus x squared minus 24x plus c. To find the c, we have to find y value, right? So what we have to do is we have to okay, so hold on. The minimum value is negative 46. So from this, we can find the x values of turning points. So 2x squared plus 2x minus 24 equals 0. And x squared plus x minus 12 equals 0. Hence x, so factorize it, x minus 3 times x plus 4 equals 0. X equals 3 or negative 4, right? So if I draw this graph, the cubic graph should be this, and the first one is negative 4, and second turning point is 3. It means that, and it says local minimum is negative 46. So obviously when x is 3, y gets negative 46. That's the coordinates we need, right, to find the c. So plug a 3 into this function, right? So when I do that, so here, 18 plus 9 equals 72 plus C equals negative 46. And then you will find C equals negative 1. Hence, complete f of x. So that's a 2x cubed over 3 plus x squared minus 24x minus 1 should be the answer. Awesome. All right, next. Question D. This can be a bit tricky question. Let's see. A cruise ship, the Helena, moves at a constant speed 5 meters per second. A passenger who missed the ship gets onto a smaller boat. The smaller boat accelerates at 0.5 meter per square second to catch up to the Helena. When the smaller boat leaves the dock, the Helena is already 200 meters away from the dock. Find the distance from the dock at which the smaller boat catches up to the Helena. Now, it's like this. So say this is a cruise and there's dock. My drawing is not that great, but and this is small taxi boat. And when it started, it is about 200 meters away. That's the situation. Now, let's start with the small boat, right? So we've got to find distance, right? So the plan here is we find the distance in terms of a small boat, the small boat, and we find the distance function, displacement function for cruise, and they are the same. So solving, you know, the simultaneous equation, and then we will find distance. All right. So first, velocity equals, you have to integrate acceleration, isn't it? So which is 0.5. So that gives me 0.5 t plus c. Now you think about it. When it started, so initial velocity must be 0, isn't it? Because it stopped and it started. So in this case, c must be 0, right? So hence v is 0.5 t. So I would say v of naught is, well, what, which is a c equals 0. That's why. So that's velocity, and then we go displacement function is we integrate velocity 0.5 t dt. So that gives me 0.5 t squared over 2 plus c, which is 0.25 t squared. And again, because s of naught must be 0, isn't it? Because this is a reference point, right? So it starts from 0. So hence c must be 0, right? So that's why we get 0.25 t squared. All right. This is about small boat, SB. Now, what about cruise? So first of all, starting with displacement function, s equals integral 5 dt, isn't it? Because it says the velocity is 5. So that is 5t plus c. Now, what about when t is naught, time is 0, initial distance? Because do you remember this diagram? This is a reference point, which is 0. It is 200 meters away, isn't it? So when t is naught, c must be 200, isn't it? Right? So hence, I could say S equals 5t plus 200. Okay, that is cruise. Now, as I said, we have to solve simultaneously because the distance is the same. So that means 0.25 t squared, which is the small boat, equals the cruise, the distance of the cruise, 5t plus 200. So we rearrange it. 0.25 t squared minus 5t minus 200 equals naught. And I times by 100 and divided by 25 gives me t squared minus 20t minus 800 equals 0. And then you solve this equation. You get t equals 40 or negative 20. Obviously, negative 20 doesn't make sense. Time can't be negative, right? So hence, when t is at 40 seconds, the distance is the same. So then the actual distance when this small boat catches up with the cruise must be, so either function. So I'm gonna use this small boat. So we plug S of 40 equals 0.25 times 40 squared gives me 400 meters, right? So as I said, if you plug 40 into that function, obviously you also get 400 meters. So when the boat runs 400 meters, it catches up with the cruise. All right, cool. Next question 2. All right, I'm going to carry on question 2 and then I'm going to have a rest. So question 2 says, given the graph of f of x below, sketch f prime x here. So here, two things you have to show. I will just make it smaller. These turning points, I'm going to draw a line. So those should be x-intercept for gradient function, right? And another thing you have to see, because it's a quartic, so there are four, technically, there are four roots. So that's a quartic. Now, the derivative must be cubic. So this is a positive quartic, isn't it? So you expect to draw positive cubic. So should be this shape. So I would go up and down and up again. So make sure those turning points matching with x-intercepts. And this is a positive, so derivative is positive as well. Two things you have to show. All right, next. Question B. Make it bigger again. So f prime x is there. The graph f of x passes through 2, 5. Find the equation of function f. So in that case, we have to integrate, isn't it? So f of x equals integral 2x cubed minus 6x squared plus 2x plus 4 dx, right? So you get 2x to the power of 4 over 4 minus 6x cubed over 3 plus 2x squared over 2 plus 4x plus c, which is x to the power of 4 over 2 minus 2x cubed plus x squared plus 4x plus c. Now, to find the c, we have to use this information. So f over 2 is 8 minus 16 plus 4 plus 8 plus c. That should be 5. That means c must be 1, right? So hence, you must complete that equation. x to the power of 4 over 2 minus 2x cubed plus x squared plus 4x plus 1 is final answer. All right, next. Oh, this is an interesting question too. Hemi is part of a student's research project on how caffeine enters the bloodstream. A new device measures caffeine levels in his blood. He is monitored for 180 minutes, and at some point, he is given a cup of coffee to drink. His caffeine levels can be modeled using this equation. All right, where C is the concentration, microgram per liter, and T is time in minutes. Show that the rate of change of concentration is minus 16 micrograms per liter per minute after he has been there for 60 minutes. So all you have to do, this is obvious, you differentiate C prime T, and then plug 60, isn't it? So that is T squared over 50 minus 2.8 T plus 80, and then you plug 60 equals 3,600 over 50 minus 2.8 times 60 plus 80 gives me minus 16 micrograms per liter per minute. All right, that's good. And the question 2, use calculus to justify when Hemi was given the coffee, assuming the caffeine enters the bloodstream as soon as it is consumed and continues to increase for some time after consumption. Good question. Right. So I believe we have to, draw the graph so that we would know when is the maximum, right? And when is the minimum. Okay. So I'm just looking at the question again. I see. Okay. So obviously it starts from 0. So like a no 250. So at the beginning here the 250 micrograms. Right. So to draw the graph, obviously we have to see the graph is positive cubic, right? So that means looks like this, and we are gonna differentiate the derivative, which is already there, should be 0, isn't it? So I'm saying that should be 0. Yeah. So I'm gonna repeat that. So t squared over 50 minus 2.80 plus 80 must be 0. Hence t squared minus 140t plus 4,000 equals 0. Right? So when you solve this, t equals 40 or 100. So that means this is 40 and that is 100. So that is time, isn't it? So, well, oops. So, when Hemi was given that coffee, so I do believe at the beginning he had coffee, and it's like a maximize up to like 40 minutes, right? After 40 minutes, it drops, yeah, and then after hundreds minutes, he was given another shot, another coffee, and he had caffeine in his bloodstream. All right, so that's what we have to say. But I'd like to find, how far it went. I mean, what was the maximum, caffeine in his bloodstream. So what you have to do is you have to plug 40 into, not F, sorry, C, isn't it? So uh, C over 40, if you calculate, so if you plug that into the equation, original equation, it becomes 240 micrograms per liter. Now, so that means this is 240, isn't it? So I would say, according to the graph, so the caffeine level increases till 40 minutes. Then it drops 100 minutes later. He gets another coffee. Hence, his caffeine level increases again. That's what you have to say. All right, cool. Next, so question D. A function f of x is given by that where a and b are constant. The graph of f of x intersects the x-axis at x equals 1 and has a stationary point at x equals -1. Use calculus to find the x coordinates of the other stationary point. And question 2, use calculus methods to determine what type of stationary point this is. I was quite surprised. This is like the vocabulary is level 3. So first of all, a stationary point is turning point, and also point of inflection. That's called the stationary point. And second, it says use calculus to determine what type of stationary point. So far, you didn't have to, meaning just use a graph to determine whether this is like, for example, if you have a cubic graph, the first one must be local maximum and second one must be local minimum. But when it says use calculus, that means you must use second derivative, right? Second derivative is negative, that is a local maximum. Second derivative is positive, that is local minimum. And second derivative is 0, that is a point of inflection. Okay, so let's do that. I'm gonna rub this out. All right, so x coordinates of other stationary point. All right, so what I'm gonna do, because f of x intersects the x-axis at x equals 1, so I'm gonna plug 1 into f of x. So when you plug 1, I get what a plus b plus a plus 2 equals 2a plus b plus 2 equals 0. So from this equation, I can say 2a plus b equals -2. That's the first equation. So what I'm gonna do is I will find a and b first through these information, and then I differentiate f of x, so which is 3ax squared plus 2bx plus a, right? And then I plug -1 because it is a station point, which is yeah, can be point of inflection, but I assume that it's a point, turning point. So when I plug -1 into this, I get 3a minus 2b plus a, which is 4a minus 2b equals 0. So that means 2a minus b equals 0. That's the second equation. So if I add first and second, so first is this and second is that, what do I get? I get 4a equals -2. That means a equals -half. So when a is -half, use either 1 or 2, number 2 equation. B turns out -1. Okay, so hence I can answer the first question. Find the coordinates of the other stationary point. So f prime x is -3 over 2x squared minus 2x minus half, right? So I just plug the a, b into this. And then I set this one 0, right? And then what I do, I times by -2. So I get 3x squared plus 4x plus 1 equals 0. So that means x plus 1 times 3x plus 1 equals 0. So x equals -1 or -1/3. So this one already said -1. So the other answer is -1/3 is the answer. For question I. Oops. -1/3. Okay, second question. What is this? I mean, what's the nature of this stationary point? I don't really like this question. I'm gonna read this again. It says, use calculus method to determine what type of stationary point this is. I assume this is about other stationary point, but some students might think this is when x is -1. So it's not that clear. So what I'm gonna do, if I were you, I would just, show both of them, So I would plug second derivative. I mean, I have to calculate the second derivative first. So from this, I get second derivative is -3x minus 2. So what you have to do is just differentiate again, right? So this is second derivative. Then I plug -1/3 first, so which gives me 1 minus 2, which is -1. So this means what? Local maximum. And so I would say at x equals -1/3, local maximum. And I will just do with -1 as well. So that gives me 3 minus 2 equals 1. So hence, because it's positive, at x equals -1, it is local minimum. Okay, so I assume this is the answer, but yeah, for safety, I write when x is -1 as well. All right, I think I'm gonna have a rest, and I will see you later. See ya. Bye.